Good morning. Today we are doing problem 1110. It's on page 450 and 451 of your book, and it's another example of all the variances that we cover in chapter 11. So in this problem, part A asks us to calculate the standard cost per unit, and we're given lots of little bits of information that we need to sort out. The first thing is materials. We're told that it takes 3.5 pounds of materials to make a unit, and that the materials cost $3.40 per pound. So multiplying that together, our standard cost for direct materials is $11.90. Right there. And then for labor, we're told it takes 0.5 hours to make a unit, and that the workers are paid $20 per hour. So we have a standard cost of $10 for direct labor, multiplying that out. And then for overhead, we're told that the overhead rate is $7 in total, and that 6 of it is variable overhead, which means $1 must be fixed overhead. And our total standard cost is $28.90. Now you could have figured out the fixed overhead from another method. The total fixed overhead was $100,000, and at the beginning of the year we expected 100,000 units to be made, so we would have applied it using $1 per unit. So that's just another way you could get there. All right, so that's part A. We have our standard costs. Part B starts all of the variances. So the first one we'll do is the materials price variance. You notice that I have a formula here. It's actual price minus standard price multiplied by the actual quantity purchased, because at the purchase date you lock in the price. So we are told some information. We have our standard price, which is $3.40 per pound. We still don't have the actual price, so we'll come back to that later. And we purchased 350,000 pounds. And this actually leads us to how we can get our actual price. So we purchased 350,000 pounds for $1,260,000. So if we divide that, we can determine that we paid $3.60 per pound when we bought the goods. So we'll put that into our actual price. So 360 minus 340, and then multiply by 350,000 pounds. That's going to give us our actual variance number, which is $70,000, and it's unfavorable in this case. It's unfavorable because we paid more in reality than we had planned on paying. All right, let's move this thing up and do our quantity variance. So quantity variance is actual quantity used minus the standard quantity times the standard price. We are given our actual quantity used, which is 341,550 pounds. And we have to calculate our standard quantity, so we'll come back to that. And we know that our standard price is $3.50. So our standard quantity has to be adjusted from the per unit amount to what we actually made in units. So the actual seals that we produced were 99,000 seals, and we had planned to only use 3.5 pounds of materials per seal. So our standard quantity is 346,500 pounds. So now we'll plug that into the equation and solve. So we have with a negative 16,830. In this case, it's favorable because it means that we use less materials than we had planned. So hopefully if you talk yourself through it that way, it'll make some more sense. Okay, let's keep going on with our variances. Our next variance is the labor rate variance. The labor rate variance equation is written up on the top here. It's actual rate minus our standard rate multiplied by our actual hours. So in this case, we are given the actual rate and the standard rate. So we have $21 for actual rate, and our standard rate is 20. But what we need to find is our actual hours. So we'll do that over here. We're told our total labor cost is $1,039,500, and that the rate again is $21 per hour. So if we divide, that means that we can figure out the number of hours. So we have 49,500 hours were used to make all of our products. So 21 minus 20 times 49,500 gives us a variance of 49,500, and this is unfavorable. Let's look into why, because we paid more than we had planned to pay. Okay, so for the labor efficiency variance, our formula is actual hours minus standard hours multiplied by actual rate, and we have we had just calculated the 49,500. That's our actual hours. We are not given our standard hours, so we'll have to come back there. And we know that our standard rate is 20. So let's figure out our standard hours. We know the total number of seals is 99,000. That's what we actually produce as our actual production. And we know that our standard hours per unit was 0.5 hours per seal. So if we multiply them, we can calculate that we had planned to spend 49,500 hours on making these seals. And if we put this into our equation, we find that we have a 0 variance for this one. So we have 0 there. So we had done exactly as we had planned. Okay, on to the overhead variances.